All right, so I think this is recording. Let's take a look at solving these three equations. They are rational equations, ratios or fractions, and we see that we have variables in the denominator. So whenever we have variables in the denominator, we have to be concerned about the solution set because there may be extraneous solutions. Let's jump in and take a look at number 7. On the left-hand side, we want to factor that denominator because with these ratios, we need a common denominator. At least that's the technique that we're going to use, is to get a common denominator in all terms. So on the left-hand side, it's easy to factor this trinomial with the leading coefficient of 1. We need two numbers that when multiplied together give us a -8, but yet when added together give us a -2. And -4 and +2 accomplish that. Well, that's the denominator that we're going to want to see in every term. So on the right-hand side, we can see this x minus 4 is missing that factor of x plus 2. So to get that factor of x plus 2, we multiply this denominator by x plus 2. But you can't come in and just change the problem like that. So we make the numerator also equal to x plus 2. So I often just jokingly refer to this as the number 1 in disguise, because x plus 2 divided by x plus 2 is the number 1. It's just not very often do you see it written like that. All right, so here in this second term, it's the same idea. We have an x plus 2 and we're missing an x minus 4. And we can't just come in and write x minus 4 in the denominator just because it pleases us. But what we can do is multiply this fraction by the number 1, because the number 1 is the multiplicative identity. When you multiply by 1, you get the identical thing back. All right, so now that all of these terms all have the same denominator, we can multiply both sides of this equation by that common denominator, and we say that we clear the fractions, we clear the denominator, that all we have left is the numerator and the operations that are going on in the numerator. 1 times x plus 2 is just x plus 2, and here we have 5 times the quantity x minus 4. Now, it's possible, however, that when we multiply both sides of this equation by a variable that we introduced extra solutions. There may be solutions to this new equation that are not solutions to the original equation. So we have to look at it and see, well, what values of x would not be allowed in our solution set? Well, any value of x that would cause division by 0. So I'm going to make the remark here that if x were allowed to be 4, I'd have 4 minus 4, and that's a 0 in the denominator, and I can't have that. And if x were allowed to be -2, I would have a 0 in the denominator, and I can't allow that to happen. So let's solve this equation, see what solution it gives us, and make sure that 4 and -2 are not in our final answer. So on the left-hand side, we have 6. On the right-hand side, we have x plus 2 minus 5x plus 20. Multiplication distributes over subtraction. And we have like terms on the right-hand side that we want to combine. 1x, take away 5x's, -4x, and plus 22. If we subtract 22 from each side, then we have -16 is equal to -4 times x, or that divide each side by -4, -16 divided by -4 is a +4. However, +4 was one of those values that would not check in the original solution. It's an extraneous solution. Yes, it's a solution to the equation here that resulted when we well, the one above it, when we cleared our denominator. Yeah, it satisfies this equation, but when we multiply both sides of this equation by our x minus 4, that'd be we wouldn't be able to do that if x were allowed to equal 4. So our final answer here is that there is no solution. That was the only candidate, and we have to throw it out because it causes division by 0. All right. We take a look at number 8, we want to attack it in the same way that we did number 7. We looked at the denominators, and we want these denominators written in factored form. So I can't do anything with the x minus 3 and x plus 1, but on the right-hand side, I can clearly factor this x squared minus 2x minus 3. And oftentimes it's the other factors over here too. So if you get a little bit stuck, take a look at those and see if when you multiply those together, you don't get x squared minus 2x minus 3. So this factors to the x minus 3 times x plus 1, because negative 3 times a positive 1 is negative 3, and when you add negative 3 and positive 1, you get a negative 2. So here on the right-hand side, that's the denominator that we want every term to have. So on the left-hand side, this first term is missing a factor of x plus 1. So we come in and put an x plus 1 in the denominator, but the only way that we can really do that is if we're clever and multiply by the number 1 and write the number 1 in disguise and write it as x plus 1 over x plus 1. So the same idea occurs with the second term, and so we multiply it by x minus 3 over x minus 3. On the right-hand side, it has the denominator we want, so we don't have to modify this at all. So we multiply both sides of this equation by this common denominator. All these denominators cancel, and we have only the operations left that are in the numerator. 1 times x plus 1 is just x plus 1. We have minus 2 times the quantity x minus 3. On the right-hand side, we have 8. And this equation, however, when we multiply both sides by that variable, by the common denominator, we may have introduced solutions that satisfy this equation that don't satisfy the original equation. We can't allow x equals 3 to be in our solution set, and we can't allow negative 1 to be in our solution set because they cause division by 0. So let's see what we get here when we solve for this equation. We have 1x plus 1 minus 2x plus 6 is equal to 8. So on the left-hand side, we need to combine these like terms, and I get negative 1x plus 7 is equal to 8. If I subtract 1 from each side, 8 minus 7 is 1. And I get a negative 1, but I know that I can't allow that to be in my solution set for the original equation because it causes division by 0. Yes, it's true that x equals negative 1 is a solution to that resulting equation after I cleared the fractions, but when I multiplied both sides of this equation by a variable, it was under the assumption that I'm multiplying both sides of this equation by a number, not by something that's undefined. So this is extraneous, and we have no solution. I just made a video of 3 problems, and I'm hoping I'm not making a video of the same 3 problems that I just did. I can't remember which those problems were. But I do remember that the first 2 of them had no solution. All right, so let's continue anyway, though. In number 9, we have denominators of x plus 4, but this minus 7, although it's not written, it's not emphasized, it has a denominator of 1. And we need the denominators to be the same for all of these terms. So we're going to multiply that 7 by x plus 4 over x plus 4. And now these three terms all have the same denominator, and we can clear our fractions. We can cancel these denominators. If we multiply both sides of this equation by x plus 4, what will we have? We'll have 3 minus 7 times the quantity x plus 4 is equal to negative 4. But that'll only exist as provided that x is not be allowed to be negative 4. If I get that in my solution here, it may be a solution to this resulting equation, but it's not a solution to the original equation, because if x were allowed to equal negative 4, we would have division by 0. So let's solve this equation. The multiplication distributes over addition here. And we have like terms here to combine. And if I add 25 to each side, 25 minus 4 is 21. If I divide both sides by a negative 7, I get that negative 3 is my solution. So that does not cause division by 0. So if I haven't made a silly mistake here, this x equals negative 3 should check. If you plug it in and get a number on the left-hand side, and plug negative 3 in and get a number on the right-hand side, those numbers should be the same. It should satisfy this original equation. So hey, ask questions if you have them. I hope this helps, and I will talk to you later. Bye.